Alright, in this video I'll be covering section 11.7. Notice here it starts, well, these are events involving and. So we sometimes call it, well, these are and probabilities. So notice the definition here. It says two events A and B are independent events if the occurrence of either of them has no effect on the probability of the other. So one occurring has no effect on the probability of the other. So for example, and by the way, when we're doing and probabilities, this idea of independent or not is really important because we treat them differently. So with independent events, an example would be flipping a coin or rolling a die is event A, and flipping a coin would be event B. When you roll a die, that has no impact, or it's not going to affect the probability when you flip your coin. You're still going to have a 50% chance of getting a king, or a heads or a tails. So the probability of neither event is affecting the probability of the other event. An example where the two events are not independent would be if two cards are selected from a deck of cards without replacement, the events being the first selection of a card and the second selection of a card are not independent. Basically, the reason why is because once that first card is drawn, there's no longer 52 cards to choose from when you make the second selection. And so that does affect the probability of the second event. So let's go ahead and do some examples. We'll start with independent events. So it says here, if A and B are independent events, then the probability of A and B occurring is equal to the probability of A times the probability of B. So we just multiply the two probabilities. So if a coin is flipped twice, what is the probability of getting two heads? So the way we write this is the probability of getting a head and then a head is equal to the probability of getting a head times the probability of getting a head. Again, these flipping a coin the first time and the second time, these two events are independent because no matter what you get the first time, that has no effect on the probability the second time as far as whether you're going to get a head or a tail. It's always 50-50 or a 1 in 2 chance. So here each of these probabilities is a half, and we multiply, we get 1/4. So your probability of getting two heads when you flip a coin 2 times is 1 in 4. Alright, so number 2 works the same way, except for now we have 3 boys, or we're having 3 events. So each time you have a child, that's considered an event. And each time the probability of getting a boy is 1 in 2. So these are independent events. So no matter how many boys a person's already, or a mom's already had, the next time she has a child, the probability is still 1 in 2 that she would get a girl. Alright, so the probability of having 3 boys is the probability of getting a boy and a boy and a boy. And so this is just going to be found by multiplying those 3 probabilities. Each time the probability of getting a boy is 1 in 2. So when you multiply across, you get 1/8. So in a previous problem, we actually wrote out the sample space, all the possible outcomes when you have 3 children, and we were able to use the sample space to see that the probability is 1 in 8. Here we're using an and probability to get the same answer. So go ahead and try number 3, and then I would encourage you to check your answers on the video. Alright, so probability of getting a blue and a green. Well, notice when I flip or spin this spinner, each time I have a 1 in 4 chance of getting any of the 4 colors. And it doesn't matter if I get a blue the first time, it's still going to be probability of 1 in 4 that I get a green on the second spin. So the first event has no effect on the probability of the second, so these are independent events. So the probability of getting a boy, or I'm not sorry, how about getting blue and green is the probability of getting blue times the probability of getting green. Each time we get 1/4 for those, and when you multiply you get 1/16. So there's a 1 in 16 chance that you'll get a blue and then a green. Probability of getting 3 reds in a row, that's, I'll just put R and R and R. So each time the probability of getting red, well, we're going to multiply the probabilities. Each time the probability is going to be a 4th. And if you multiply the 1s, you get 1. You multiply the 4s, you get 64. You're going to get 1 in 64. All right, let's move on to the next slide. In number 4, excuse me, this is, I would say this is an unnatural situation here. It says you draw 2 cards from a deck of cards with replacement. That means I'm going to draw the first card and see what I get, and I'm going to put it back and draw a second card. That's not really normally how it works, but there's a number of these in the homework, so I wanted to make sure you saw at least one of these. But anytime it says with replacement, that means I'm putting back, restoring things to how they started after the first event. So let's see, what is the probability of getting 2 aces? Well, the first time, well, first of all, it's probability of getting an ace and an ace. It's the probability of getting an ace times the probability of getting an ace. Basically, because each time, excuse me, since you're putting your card back after you pick it, you're going to have 54 cards to choose from again. And if you got an ace, you're putting it back, so you're still going to have 4 aces to choose from. So each time you have a 4 in 52 chance of drawing an ace. These fractions simplify to 1 over 13. So when I multiply across, you can see that you have a 1 in 169 chance to draw 2 aces when you draw 2 cards from a deck of cards. So not very good chances there. So what if the events are dependent events? Well, the probability is a little bit different. We're still multiplying. Notice here it says for dependent events, probability of A and B is equal to the probability of A times the probability of B given that A has occurred. So let's look at number 5 and see how that works. So you draw 2 cards from a deck without replacement. What's the probability of getting 2 aces? So the probability of getting an ace and getting an ace. So that's going to be the probability of getting an ace times the probability of getting an ace, given that we already drew an ace in the first draw. However you want to say that. So the probability of getting ace when you draw the first card is 4 out of 52. Now think about this. You're holding your ace because your chances of getting 2 aces, you're assuming you get an ace the first time. So you've got an ace. So now the second time you draw, there's no longer 52 cards. There's now 51. And there's no longer 4 aces. You already drew one, and so there's now only 3. So the probability of getting an ace the second time is 3 in 51. These both reduce. And when you multiply across, you get 1 over 221. Don't forget to use your calculators to help you simplify these answers. The most important part of this chapter is that you understand how to do the probability. All right, I would encourage you to try number 6. It's very similar. And then you may want to try number 7 as well, and then watch the video. All right, so it says if a bag contains 3 red marbles and 5 blue marbles, and 2 marbles are chosen without replacement, find the probability of choosing 2 red marbles. So these are dependent events because when you choose the first marble, you're no longer going to have the same number of marbles to choose from when you choose the second marble. Not to mention, if you choose a red the first time, that means there's fewer red marbles to choose from the second time. So it's still probability of red and red with dependent events is equal to the probability of getting a red times the probability of getting a red given that you've already chosen a red on the first draw. So probability of getting a red, well, there's 3 red marbles out of a total of 8, 3 plus 5. But now when I choose the second one, the probability of getting a red marble now, there's only 2 red marbles left, and there's only 7 total marbles left. So 2/7 is the probability of getting your second red. And now if you multiply these across and reduce, you get 3/28. All right, last problem. Oops, did I lose something here? There we go. So 3 people are randomly selected, 1 person at a time, from 5 freshmen, 2 sophomores, and 4 juniors. Find the probability that the first 2 people selected are freshmen and the third is a junior. So you want to find the probability of choosing a freshman and then a junior. So I'm just using F for freshman and J for junior. So it's the probability that you get a freshman times the probability that you get a freshman given that you drew a freshman first, or selected a freshman the first time, times the probability of getting a junior given that you've already selected a freshman and a freshman in the first 2 selections. So the probability that you choose a freshman on the first choice, well, there's 5 freshmen to choose from, and if you add 5, 2, and 4, there's a total of 11 people. So you have a 5 in 11 chance of choosing a freshman on the first selection. And now you've already chosen a freshman, so now there's only 4 freshmen to choose from, and there's only 10 people now to choose from. So the probability is 4 in 10 that you'll choose a freshman on the second selection. Again, these are random. And then the last selection, you've already chosen 2 freshmen, and you're and you choose a junior this time. The probability of choosing a junior, well, there's still 4 juniors, and there's now 9 people to choose from, so 4 ninths. We can reduce the 4 tenths, and notice we can cancel those 5s, and now when we multiply across, we get 8/99. All right, and that's the end of this video.